Hello, this is Geyang here with my partner Eric, and we did some research on cybersecurity and IoT. First, what is IoT? IoT stands for Internet of Things. So, that includes things that sense and collect data and send it to the internet. So, really, it includes everyday objects and devices around us. And the idea of IoT Hub is it connects to all of your IoT devices and easily control and protect them. For example, IoT Hub display device information such as battery life. It can control and limit access of devices. It can notify users of device activities. And really, IoT devices around us in everyday lives. For example, in your smart furniture, including smart lamp or like smart kitchenware, so your smartphone, like all of those are within the range of IoT device. And fun fact, the first ever IoT device was actually the vending machine in CMU's Wing Hall in the 80s when a student decided to make a program that he can see from a distance what the coldest Coca-Cola is, like where it is in the vending machine. So as we see from the figure, the IoT device is growing every year. It is actually estimated that the number of IoT devices is expected to grow to 21 billion by 2020. So despite the growth, we also have issues that come along with it. So as we see, like for example, we have too many IoT devices to manage. It may have low computational power. It may lack the ability to receive software updates, or just not manufactured well. So all these issues lead us to research on ways to improve them because we really cannot afford the attacks from malicious people. For example, we can have very private information, like such as our health records, and we really don't want that fall into some bad guys' hands. So there are a few research fields that people are thinking of, like ways to improve security. So the first one, network security, is about setting up biometrics. So for example, fingerprints or like iris scan. So like for the information, it can be either something user has, for example, smart cards, smartphones, or something the user knows, for example, passwords, or something the user is, for example, fingerprint. And that's the hardest part to get from a person. So as we see, the single factor authentication can be easy to breach. And so we need multi-factor based user authentication for more secure IoT devices. So in order to encrypt the biometrics information, we cannot directly do it because the data changes with time and environment. For example, voice or fingerprint scanning. To resolve this issue, researchers have suggested using perpetual hashing, which is a technique that generates a hash value dependent on the multimedia content and it remains approximately the same if the content is not significantly modified. So the next thing is trust management. It's another way people are thinking of to improve security. So in order to verify the trust and the privacy of nodes, we need to research a new remote attestation mechanism which can apply to sensing layer nodes. Some research focus on a remote attestation mechanism for the sensing layer nodes in the Internet of Things. Remote attestation is a method to report the configuration information to remote platform and verify the basic information and the authenticity. And it's a really hot topic in cybersecurity and IoT hub right now.
And another possible field of research is the actual encryption of both data and also the user's ID and the password to make sure the user has authentication to access the data and the services of the IoT devices. This is especially important in the healthcare industry. For example, if a lot of IoT devices are used for telemonitoring of people's personal health, such as the blood pressure, and this kind of info, if being lost, is very costly to a person with their health info being breached, being known by other people with malicious intent. Therefore, we need to encrypt we need to encrypt the data in a secure manner. And one of the research we have is to use the elliptical curve cryptography to find the prime number on the elliptical curve, and then choose the computer encoding with the prime number we have, and decoding encoding process with the XOR operations we have, and to make sure the data which is being transferred is secure. The one reason we use elliptical curve cryptography is that they have the prime number choose on the elliptical curve is way smaller expected than just choosing a prime number from scratch, and this will make our process goes faster and makes our Internet of Things more secure by giving the speed. The other one is the meaning of the new technology, such as the blockchain. And one research we have on blockchain is to form a bubbles of trust using public blockchain group and controlled by the one master node of the entire public blockchain. And the entire public blockchain is formed by a group of IoT devices that communicate with each other. For example, if in a household, it will be the TVs, the fridges, and the Google Homes you have that used to manage all of them and will be the same system. And each device can only communicate with the devices within the safety zone of the blockchain, which is within the system of the bubble of trust, to make sure the devices on the blockchains are secure and make sure the security is very fast and efficient. At CMU, we have three different labs and three different organizations that helped us in doing the IoT security devices research. The Scilab has the Scilab does the security priority research in all kinds of software field, while the Institute for Software Research does innovation in software research in both IoT devices and make sure the IoT devices are secure. Furthermore, we also have the IoT Expedition, which is a cooperation between CMU and the faculty from other colleges such as Cornell, and also researchers from Google, to make sure it's a large-scale deployment of Internet of Things that is extensible, privacy-sensitive, and end-user programmable for the future users. And going into more of the IoT expedition, which we found it very interesting, and is co-led by one of the professors in CMU called Professor Agarwal, and he recently developed GIOTTO, which is the infrastructure for IoT at CMU, and is also the infrastructure they want to use for the IoT large scale deployment. And then one of the features it has is to give data priorities in a need to be secure order. So the more prioritized data will be have a higher need to be secure, will be higher measure to make it secure. And in future works for in terms of cybersecurity and IoT, we see that GIOTTO is still under development, and we can always apply more security measures. And we will talk to Professor Agarwal in the future. And we can also explore more in emerging technologies with not only blockchain but also other developing such as ML and AI currently. And we can also think of the scalability of security measures as IoT devices usage is continuing to grow, as we show in the first diagram we see in the presentation. Thank you guys for listening, and please let us know if there's any questions.